In this video, we're going to go over a couple of questions, specifically conceptual questions that relate to just charge in general. So electric charge. As usual, answer the question on your own first and then watch the solution. So here is the first question. What do you think here? So the correct answer is D. So just side note, a pith ball is just a little teeny tiny styrofoam ball. So we have these two really small balls. They are charged and they hang on strings. Well, we know that either one of them just hanging from a string would hang straight down because the pull of gravity would pull it straight down. The fact that they are not hanging straight down means sphere 1 is experiencing some sort of force to the left, and sphere 2, or ball 2, is experiencing some sort of force to the right. So these must be repelling each other. If they're repelling each other, then we just know they're both the same. But there's no way to know if they're both positive, or both negative. We just know they have to be the same if they are repelling. Okay, we have one more conceptual question. What do you think about this one? The correct answer here is C. Now we need to go in order on these. So this charged rod is brought near. Since this rod is positively charged, the positive sign's drawn on it, that will attract electrons. Not all of the electrons, but some of the electrons, which in turn leaves a net positive charge on that far other side. Okay, so that is step A. Step B, we're separating the spheres, meaning the rod is still there. So sphere 1, we still have this. Sphere 2, we've removed the contact between sphere 1 and sphere 2. Okay, that's the end of B. C, we now move the rod away. Well, if the rod is moved away, these electrons are no longer attracted to it, but there's no longer a path to get back to sphere 2. So we needed this physical contact between the spheres for the electrons to move between spheres 1 and 2. So again, I didn't mention this before, the fact that they are metal spheres is important. Excuse me, metal is a conductor, meaning those valence electrons, the outside electrons in any one atom, easily move from one atom to the other, which means they will also move from between sphere 1 and 2 very easily because they are in contact. Any contact allows those electrons to move freely between the conducting objects. When we remove contact, they are not able to go back and forth now. And so we're left with sphere 1 having a net negative charge. So as I mentioned in the video on charging, we're going to use Q to represent charge on an object. Sphere 2 will have a positive charge. Now, capital Q versus lowercase q, it doesn't really matter. As we start talking about charges interacting with each other, we might use a lowercase q to represent one and a capital Q to represent the other, just to make that distinction. But lowercase q and capital Q both represent the net charge on an object.